On this video, I'm going to talk about the Laplace, the properties of the Laplace transform. Okay, so the first property of the Laplace transform is if Fs, the uppercase Fs, is the Laplace transform of Ft, then if you multiply this function by e to the ct, then the Laplace transform will be changed by just by s minus c. Okay, if there is a plus c, there will be s and then minus c. So you will just replace s by s minus c in the Laplace transform. You see that? So how do I show that? Is this quantity. So basically Laplace transform of e to the ct and then ft, right? So this will become integral 0 to infinity e to the ct and then times e to the negative st, right? And then f of t dt. You see that? So this will become 0 to infinity e to the negative s minus ct. You can write it that way, right? F of t dt. So this is basically the uppercase s minus c. This is in the Laplace transform form, right? Because you see, like, e to the negative alpha t ft dt. So it will be f of alpha, right? So it is s minus c basically. So I just use followed the formula there, right, of the Laplace transform. Let us use this in our formula directly to do this. What is the Laplace transform of this? What is the formula for Laplace transform of sine 4t only? If there is sine 4t, then the Laplace transform is for this quantity only. For this quantity only, the Laplace transform is basically 4 over s square plus 4 square, that is 16, right? Because it is for the sine at, the Laplace transform is a over s square plus 16. But you are multiplying sine at or sine 4t by e to the negative 3t, right? If there is negative, if c is negative, there will be positive there, right? If c is positive, there will be negative. So it's like that. So the formula will be, you will have, let me write like this. So since, so I write since Laplace transform of sine 4t equals to 4 over s square plus 16. This is fs, right? Now you will have to replace s by s plus 3 because there is negative, right? If there is positive c, then it will be s minus c. So if there is negative, then that will be s plus, right? So then, so the Laplace transform of e to the negative 3t sine 4t equals to how much? It should be fs minus, this is fs, right? So basically this is f of s. This quantity is f of s, right? When you multiply by e to the ct, c is negative 3. So when you multiply by e to the ct, it will be f of s minus c, right? But c is negative, so it will be f of s. This will be f of s plus 3, right? So what is the answer then? So the answer here is basically you get, so 4 over s plus 3 square, right? And then plus 16. That will be your answer. All right, so this is the property number 1. Okay, this is very important property, and then you can use this to find out the Laplace transform of so many problems. Okay, again, so if the Laplace transform of ft is fs, then Laplace transform of e to the ct times ft, multiplying ft by a exponential function, is f of s minus c. That s will be replaced by s minus c. Okay, here we multiplied by e to the negative 3. So c is negative 3. So our s will be replaced by s plus 3, right? So that's how we got. Okay, the second property is basically the linearity of the Laplace transform. What it says is, if you are trying to find out the Laplace transform of a times f, a is a constant, plus b times g, b is another constant, then you can pull that a out, and then you can do Laplace transform of f, and then plus you can pull b out as well, and then Laplace transform of g. Let us do this example just to show. Okay, so here you want to find out the Laplace transform of this. So this is same as finding the Laplace transform of this term and then minus this term and then that one. Okay, So the Laplace transform of this is basically you can find out the separate Laplace transform and then subtract this and then plus Laplace transform of 1, right? So I can write this as 2 and then Laplace transform of sine 3t, right? And then minus 5 and then Laplace transform of e to the negative twice t and then plus Laplace transform of 1. Now you plug in those values 2 times. What is the Laplace transform of sine t? Sine at has a over s square plus a square, right? So it will be like 3 over s square plus 9, right? Minus 5. What is the Laplace transform of e to the negative twice t? So e to the negative twice t will be basically 1 over s minus a, right? So it will be s. So because the Laplace transform of e to the at is 1 over s minus a, but there a is negative 2, so it will be s plus 2. And then the Laplace transform of 1 will be 1 over s. So if you simplify this, you will get 6 over s square plus 9 and then minus 5 over s plus 2 and then plus 1 over s. This is the Laplace transform. So formula number 3 or the property number 3 is the Laplace transform of f prime of t equals to s times Laplace transform of ft minus f0. If there is a first derivative, then the Laplace transform is s times Laplace transform of ft and then minus f at 0. That's what you that's the formula. Okay, let us do an example. So example is suppose ft is e to the negative twice t times sine 4t. E to the negative twice t times sine 4t, which is similar to this one. You see that? Similar to that one. So e to the negative twice t times sine 4t. Now you want to find out the Laplace transform of f prime of t. Okay, we can do this in two different ways. One way is find out the f prime of t and then find the Laplace transform. The other way is just use of that formula. Okay, let us do the use of formula first. What is Laplace transform of ft? You will have to plug in here, right? So solution. Since the Laplace transform of ft here is basically what is the Laplace transform of that? So to find out the Laplace transform of that, you need the Laplace transform of sine 4t, right? It is 4 over s square plus 16. And then you replace s by s minus c, right? So c is negative 2. So how the exactly the same way. So you will have 4 over s plus 2 square and then plus 16. This is the Laplace transform of that, right? So what is the Laplace transform of f prime of t? Let's use that formula. So Laplace transform of f prime of t will be s times the Laplace transform of ft, which is that one, 4 over s plus 2 square plus 16 and then minus f0. What is f0? Just plug in 0 for t. You'll get sine 0 is 0 times 1, right? So that will be 0. So basically what you get is 4s over s plus 2 square plus 16. This is a lot easier, right? But if you do the long way, then you find out f prime first. What is f prime? Just you need to use the product rule there, right? So if you do the f prime, then you will get this is like f, this is like g, right? So you need to use the product rule. So f prime is negative 2 e to the negative twice t times sine 4t. You see that? And then plus 4 e to the negative twice t cosine 4t. That is the derivative, because f prime is that thing times g plus f is e to the negative twice t times g prime is what is the derivative of sine? It is like sine u, right? So the derivative of sine u is cosine u times u prime, that is 4. That's what you get. Now you find out the Laplace transform of f prime. Is basically what you do is you find out the Laplace transform of this one separately and that one separately. You see that? So what will be the Laplace transform of this one is negative 2 times the Laplace transform of this is 4 over s square plus 16, but there is negative 2. So s will be replaced by s plus 2. So 4 over s plus 2 square plus 16, right? Plus 4 times. what is the Laplace transform of cosine 4t? So the Laplace transform of cosine 4t will be let me ask you this. What is the Laplace transform of cosine at? It will be s over s square plus a square, right? So it will be, since there is 4, it will be like s is s over s square plus 16, but s will be replaced by s plus 2, right? So it will be s plus 2 over s plus 2 square plus 16. You see that? Why is that? Because there is e to the negative twice t. So s will be replaced by s plus 2 in the formula of cosine 4t. So the Laplace transform of cosine 4t. You see that? So this will become negative 8 over s plus 2 square plus 16, right? And then that will become plus 4s plus 8 divided by s plus 2 square plus 16, right? They have the same denominator, so what you get is, in the denominator, s plus 2 square plus 16, right? So you'll get negative 8 plus 4s plus 8, right? So what happened then is this 8 will cancel out that negative 8. So what is left is 4s over s plus 2 square plus 16. That's what you get. But you see that the use of the formula is very fast and easy. Okay, so the Laplace transform of the first derivative of a function is s times the Laplace transform of the Laplace transform of the original function, and then minus f0. How about the Laplace transform of the second derivative? The Laplace transform of the second derivative is s squared times Laplace transform of the original function minus s times f at 0 minus f prime at 0. Okay. Similarly, if you continue that, the Laplace transform of the any derivative, nth derivative, is s to the n, just follow that, right? S to the n times the Laplace transform of ft minus s to the n minus 1. You see that if there is second derivative, then you will get 1 here, right? If there is the nth derivative, you start to decrease the derivative, the exponent of s starting from that n, s to the n, and then you will get s to the n minus 1, and then f0, and minus f to the n minus 2 times f prime of 0, and continue that way, and then finally you will get s to the n minus n, that will be just s to the 0, that will be 1, and then this will increase to 1 less the derivative at 0 will, the last one will be at 1 less than what the derivative there, right? Okay, let us see 2 more examples on this. So the first example is find the Laplace transform of the initial value problem, y double prime minus 10y prime plus 9y equals to 5t, where y at 0 is negative 1 and y prime at 0 is 2. Again, if you remember the goal of the Laplace transform, right, the Laplace transform changes the differential equation into simple algebraic equation, okay, and then which will be easier to solve. That's the reason why we have to learn the Laplace transform. Okay, so let us do this. So since the Laplace transform is linear, what you can do is let me write solution. Okay, so the solution here is, so what I do is I'm taking the Laplace transform for each of those. So this will be Laplace transform of y double prime, and then minus 10 times Laplace transform of y prime, okay, plus 9 times Laplace transform of y, okay, equals to 5 times Laplace transform of t. You see that? So what is the Laplace transform of y double prime? So it is basically you can write s square, right? Because this has the formula. I'm using the formula from the from the last slide. Okay, so basically it is s squared times Laplace transform of y, right? That's what you do, and then minus, you remember that it is s times f at 0, and then minus f prime at 0. This is the Laplace transform of y double prime, right? This is just the formula. And then minus 10, what is the Laplace transform of y prime? So this is, let me write inside the bracket, s times Laplace transform of y, you see that, and then minus f at 0, right? That is the formula for Laplace transform of y prime, plus 9 times Laplace transform of y, okay, equals to, so 5 times, what is the Laplace transform of t? 5 times the Laplace transform of t is 1 over s square, right? So I will write just 5 over s square there. So this is how much. So let us combine the Laplace transform and factor that out. So if I take Laplace transform of y out, right, what is left is s square. You see that? And then there is negative minus 10s and plus 9, right? Plus 9. Now write down the other terms. S times f0. What is s times f0? F0 is basically y0, right? So negative 1. So negative 1 times s is positive s. You see that? And then what is f prime of 0 is 2. So it is minus 2. You see that? And then here negative 10 times negative f of 0 is, this is negative, f of 0 is negative 1. So negative 10 times, this is negative times negative 1, it will be negative 10, right? You see that one more time? So we have s, f of 0 is negative 1. So negative s times negative 1 is positive s. And then f prime of 0 is 2. So it is negative, f prime of 0 is negative 2. And there you get negative 10 times negative f0. What is negative f0? F0 is negative 1, so negative f0 is positive 1. So negative 10 times positive 1 will be negative 10. Okay, equals to 5 over s square. You see that? Now you need to solve for Laplace transform of y, right? So how do I do that? Is basically, let us see, what do I get there? So Laplace transform of y is equals to, can you get the factors of this just to write in the nicer form, right? So the factor of this will be s minus 9 and then s minus 1, because when you add you need to get negative 10, negative 9 minus 1, and then when you multiply you get positive 9, right? So let me move this to the other side. So 5 over s square times s minus 12, you get that? So minus, you see that, right? S minus 12, s minus 12, right? So let us simplify the right side. You will get 5 minus s square, because there is 1 in the denominator, right? Times s minus 12, see that? Divide by s square. Okay, so what do you get there then? So it will be therefore the Laplace transform of y is equals to, you divide by that quantity, right? Let me simplify the top. So you get 5 and then negative s squared times s minus s cubed, and then minus s times s squared minus 12 is plus 12s squared, right? So you'll write 5 minus s cubed plus 12s squared divided by s squared times that quantity, because I'm dividing both sides by that, right? So s minus 9 times s minus 1, which is the Laplace transform of y in this initial value problem. Okay, so without using any differential equation rules to solve this, I am able to write the Laplace transform of the solution of this one, right? So Laplace transform of the solution of this equation is like this. So next time we will do, what we will do is we'll take the inverse Laplace transform of this. Then Laplace transform and inverse Laplace transform will cancel out. Then you will be able to solve for y. Okay, that's the idea in the next section. But for now, let's continue doing another example. We are trying to find out the Laplace transform of this of the solution of this problem. Okay. So solution of the initial value problem there. So let us do that. So solution is, what is the Laplace transform of y double prime? It is basically 2 is outside, right? So the Laplace transform of y double prime is s squared, and then Laplace transform of y, right, minus s f 0 and then minus f prime of 0. This is the Laplace transform of the first term, right? And then plus 3, what is the Laplace transform of y prime? It is basically s and then Laplace transform of y, right? And then minus y, you know what, I mixed up with y and then f. So don't get confused. I did the same thing here, right? So it should be, so this should be f, right? This should be f, or you write all of those as in terms of y. Okay, so because I wrote most of them as you see that, because I wrote all of those in terms of y, some of them in terms of y, some of them in terms of f, but you understand y and f are the same thing, right? And then so y, and let me write f here too, and then f of 0, right? So what is that then? So that will be, and then how about this one? So minus 2, and then Laplace transform of y, right? So Laplace transform of y is basically Laplace transform of f. And if I know the Laplace transform of the right hand side is equals to Laplace transform of t times e to the negative twice t. This is what you get. Okay, so let us find out those values there. So what do you get there is 2. So let me collect all the Laplace transform of f. What do you get is 2s squared. From here there is a Laplace transform, right? And then plus 3s and then minus 2, right? 2. All of them have Laplace transform of f in common. You see that? So now we write down the remaining term. What is f of 0? F of 0 is 0, right? So this will go to 0, right? This is 0. What is f prime of 0? This will be negative 2 is there, right? So negative, positive 2, but there is one more 2. So that will be positive 4, right? And this one goes to 0 because f0 is 0, right? And what is next? So all of them are gone, right? So it will be in the right hand side. Now, do you know what is the Laplace transform of t? So Laplace transform of t is basically, if you remember the formula of the Laplace transform of t, it is, so we know that Laplace transform of t is 1 over s squared, right? This is f of s, right? But if you multiply by e to the negative e to the at or ct, whatever you take, then it will be f of s minus a, right? If there is a, it will be s minus a, but we have, what is our a here? A is negative 2, so this will be f of s plus 2, right? So this will become basically 1 over s plus 2 and then square. You see that? I'm using that formula, formula number 1 there. Laplace transform of f or y, right, equals to 1 over s plus 2 square minus 4, right? Now what we do is we basically divide by that. Let me show you how to write the factor of this one, and then I will divide by that factor. Okay, there is 1 in the denominator, so 2s squared plus 3s minus 2. So we need two numbers whose sum is positive 3 and product is negative 4, right? So you write 2s squared and then minus 2, sum is positive 3, product is negative 4, so it will be 4s minus s. You see that? Sum is positive 3, product is negative 4. Now you group these two and that 2, so 2s common, s plus 2, and then minus 1 common, take out, s plus 2. What are the two factors? 2s minus 1 and then s plus 2. You see that? It is s plus 2 and then 2s minus 1. So I divided by both sides by that, move that one first, and then divide both sides by that, right? So you get, so what do you get? You get 1. Let's combine the top fraction first. So you get 1 minus 4 times s plus 2 square over s plus 2 square whole divided by s plus 2 times 2s minus 1. You see that? So if you simplify that, what do you get? You will basically get 1 minus 4 s plus 2 square divided by, you just this will be multiplied that because this is 1 in the denominator, right? So this is top fraction times the reciprocal of the bottom fraction will give you s plus 2 to the cubed, right? And then 2s minus 1. That is the final answer. Or if you want to, you can just split the fraction or just keep it like this. So either way is good. Or from here you can just multiply this one by that, divide this one by that, and then this one by that is also perfectly fine, right? So you can write 1 over s plus 2 to the cubed 2s minus 1, and then minus, if you split this, 4, that square and that square will cancel out, 4 over, you can write s plus 2 and then 2s minus 1. You can end up this answer or that answer, it does not matter. Okay, these are the homework problems. Okay, section 5.2, which is the Laplace transform. Question number 2, 3, 4, 6, 7, 13 and 17. Okay guys.